Let's go to make a short proof of the second fundamental theorem of calculus. The second fundamental theorem of calculus says if you have a function that is continuous on an open interval AB, AX, X is a moving point. X is the moving point. To distinguish the X, we use the variable, the input is t. This point is when t equal x, when t equal x. So the x is moving, so the t is moving. When the t is moving, the area that is between a and x is being changing. So the area that is between a and x, the area that is between a and x, the area that is between a and x is the integral from a to x of the function, and I need to put f of t dt because the variable x is here, from t equal a to t equal x. So when I move the point x, there is a change in the area. Initially, the area was from a to x was like this. Now, if I move the point, the area will change in certain amount, that is the change in the area. So this amount for the change of the area can be the change of the area. This is smaller on this interval from x to x plus delta x will have a maximum. Let's say that this is the maximum value and will have a minimum. Let's say that this is the minimum value m. And the area that is here is smaller than m by delta x, that the area of the rectangle that you make m by delta x is smaller than, or this area is smaller and is bigger than the area for the minimum, m by delta x. So this equation I have that m is smaller than the changing area divided by changing x, and is smaller than m. Now comes the tricky part. Makes delta x to become very, very small. Makes the limits when the function, when delta x goes to 0. When delta x goes to 0, the m's goes to f of x, and the capital M's goes to the value of the function f of x. The minimum and the maximum coincide. So this is in the limit when delta x tends to 0. This is the derivative of a respect to the x. So I have no way to say that the derivative of a respect to the x must be f of x, because if it's smaller than f of x and bigger than f of x, the derivative of a respect to the x have to be f of x. But what is a? What is the area? Is the derivative respect to the x of the integral from a to x of f of t dt. So, and this is equal f of x. And this is the proof of the second fundamental theorem of calculus. There is something else, that is the net chain. The net chain is a corollary from the first fundamental theorem of calculus. The first fundamental theorem of calculus says that the area that is under the derivative of capital F, the area is f of b minus f of a. We already saw. But because capital F is the antiderivative of little f, f prime of x is f of x. So if you just substitute instead of f of x by f prime of x, you will have the equation that the integral from a to b of f prime of x, capital F of f prime of x, is f of b minus f of a. So the integral of the derivative is the change in the function, the net change of the function. And that's all.